Hello everyone, and welcome back to the Fluctus Channel. When a Navy warship reaches the end of its service life, it does not always disappear into a scrapyard. Some vessels are stripped, cleaned, studied, and sent back to sea for one final mission, becoming a target in a sinking exercise. This is known as SINKEX, and it gives ships, submarines, aircraft, and crews a rare chance to test real weapons against a full-size hull in the open ocean. Before that final day, an old ship must be decommissioned. The Navy removes active equipment, secures records, handles hazardous materials, shuts down systems, and transfers the vessel out of regular fleet service. The decommissioning of USS Bonhomme Richard showed how serious that process can be after a damaged ship is declared beyond economical repair. Crews remove gear, close spaces, prepare towing arrangements, and turn a once active amphibious assault ship into a hull ready for disposal. Other retired ships may depart for storage sites, dismantling yards, or exercises. A ship leaving the pier for the last time carries decades of operations, deployments, maintenance, and crew history behind it. Even before departure, planners check stability, watertight integrity, tow points, environmental rules, and weather windows, because a dead ship still has to move safely. During RIMPAC, the world's largest international maritime exercise, old ships can become targets for coordinated attacks. In 2018, USS Olympia, a Los Angeles-class fast attack submarine, participated in a SINKEX against the decommissioned ex-USS Racine off Hawaii. The exercise included 25 nations, 46 ships, 5 submarines, about 200 aircraft, and 25,000 personnel, turning one target into a test of alliance coordination. Inside the submarine, preparation begins long before launch. Weapons teams review orders, check safety conditions, confirm the target area, verify communications, and prepare the firing system.
Locking the bridge rails.
A torpedo or missile is not treated like a simple round. It is handled through technical procedures, locked into launch systems, and released only after the command chain confirms the ocean range is clear. When the submarine fires, the crew depends on quiet coordination. Sonar tracks the target. Fire control calculates solution data. Officers confirm depth, course, and weapon settings. The launch happens unseen from the surface, but the result is violent when the weapon reaches the ship. The target hull absorbs the strike, water rushes into damaged compartments, and the old warship begins losing the buoyancy that once kept it alive. SINKEX is rarely a single-service event. Aircraft may strike first with missiles or bombs. Surface ships may fire naval guns or anti-ship weapons. Submarines add underwater attack from a direction the target cannot defend. RIMPAC SINKEX events, including earlier exercises with USS Ronald Reagan and later events in 2014 and 2022, allow crews to practice timing, targeting, communications, and battle damage assessment. The purpose is not destruction for spectacle. It is learning how real ships react when hit by real weapons in conditions that simulators cannot fully copy. After the exercise, another lesson remains. Some old ships go to the bottom as controlled targets. Others depart for inactive ship facilities or shipbreaking yards, sometimes described as boneyards, where their metal, machinery, and usable parts enter a different life. Pearl Harbor, Naval Shipyard, and other Navy facilities hold ships that once served at sea, but now wait for maintenance, preservation, recycling, or disposal. The life cycle of a warship is therefore larger than launch and combat. It begins with construction, passes through decades of service, and ends through storage, dismantling, or one last impact in the ocean. In that final phase, a retired ship becomes both a lesson and a warning for crews. Submarines follow an even more controlled retirement path because their strength, secrecy, and machinery are hidden inside thick steel. A submarine is built to survive pressure underwater, carry complex systems, and move quietly for long periods. When it is no longer needed, disposal becomes a careful industrial process rather than a simple scrapping job. At Puget Sound Naval Shipyard, workers have handled retired submarine sections through a program designed to remove sensitive equipment, separate hazardous materials, and recycle the hull safely. The process begins with planning. Workers identify what must be removed, what can be recycled, what must be protected, and what areas are safe to cut. Electrical power is isolated. Compartments are opened. Fluids, insulation, cables, and equipment are handled according to safety rules. On older nuclear submarines, reactor compartment disposal is governed by strict environmental and technical procedures. The goal is to reduce a warship that once operated secretly under the sea into controlled sections that can be moved, stored, and processed without endangering workers or the public. Before cutting begins, supervisors review lift plans, fire risk, radiation controls where applicable, and the order in which sections will be opened. Cutting a submarine is slow and deliberate. Workers mark hull sections, set up ventilation, place fire watches, and use cutting tools to open the pressure hull. Sparks, smoke, heat, and tight spaces make the job demanding. The hull is not thin. It was designed to resist crushing forces underwater, so each cut requires patience, skilled labor, and constant safety checks. As pieces separate, crews monitor balance, rigging points, and nearby workers because a steel section can shift unexpectedly once the final connection is cut. Hull section removal is one of the clearest signs that the submarine has changed from a vessel into heavy industrial material. A section may be placed on transport equipment and moved across the shipyard. Workers guide the movement slowly, watching corners, clearances, ground conditions, and support points. Even after cutting, the section remains massive and awkward. The operation needs drivers, signalmen, supervisors, riggers, safety personnel, and sometimes multiple vehicles working as one team. Crane operations add another layer. A large crane hooks onto a dismantled section, takes the load, and lifts only when riggers confirm that slings, shackles, and lifting points are correct. The operator moves the piece through the air while spotters track every swing. The load may be placed on a barge, rail platform, stand, or disposal area. The process looks slow because it must be slow. One mistake with a submarine hull section can damage equipment or injure workers. Submarine disposal proves that the end of a naval vessel can be as technical as its beginning. The same steel that once carried sailors beneath the ocean is finally cut, lifted, moved, inspected, sorted, and reduced through careful engineering. Each cut, lift, and movement is tracked, because the disposal yard is handling history, heavy metal, and hidden risk together under strict shipyard supervision every day. That discipline safely turns disposal into engineering. The same story of retirement also happens in the sky. When military aircraft finish their service life, many make their final trip to the 309th Aerospace Maintenance and Regeneration Group, known as AMARG, at Davis-Monthan Air Force Base in Arizona. The site is often called the boneyard. It covers about 2,600 acres and has held thousands of aircraft from the Air Force, Navy, Marine Corps, Army, Coast Guard, and federal agencies. The desert location is ideal because the dry climate slows corrosion, and the hard soil allows aircraft to be parked without expensive paved surfaces. For some aircraft, the last mission is a quiet landing on a runway near long rows of retired machines. After arrival, crews inspect the aircraft, record its condition, remove classified equipment, drain fuel, safe explosive devices, and decide whether it will be stored, used for parts, regenerated, or prepared for disposal. Not every aircraft is dead when it reaches the boneyard. Some are preserved so they can fly again if needed. Others become part sources, keeping active aircraft alive around the world. That is why technicians photograph panels, log serial numbers, and protect components before the aircraft is parked in its assigned row. Aircraft decommissioning turns an airplane into a managed asset. Technicians remove invaluable components. Some parts are repaired and returned to supply. Others are tagged, stored, or scrapped. If an aircraft is chosen for demolition, crews cut wings, tails, fuselage sections, and landing gear using saws, shears, and heavy equipment. The process must account for fuel residue, hydraulic fluid, pressurized systems, composite materials, sharp edges, and environmental controls. A giant aircraft that once crossed oceans or flew combat missions is reduced piece by piece. Workers also control foreign object debris, mark hazardous areas, and keep records so each removed item has a traceable destination. Preservation is another important part of AMARG work. Aircraft stored for future use are sealed against dust, sunlight, and weather. Workers cover openings, protect engines, seal canopies and doors, and spray protective coating known as spraylat over vulnerable areas. The white coating reflects sunlight and helps protect interiors from heat. Applying it is a careful process. Surfaces are cleaned, openings are sealed, and the coating is sprayed in even passes so Arizona sun and desert dust do not destroy equipment that may be needed later. Rows of sealed aircraft may look abandoned, but many are maintained as reserves, training assets, or parts banks. From ship targets at RIMPAC to submarine hull cutting and desert aircraft storage, military disposal is not random waste. It is a controlled end-of-service system. Old ships may teach crews how weapons perform. Submarines may be dismantled through careful industrial recycling. Aircraft may be preserved, stripped, or demolished after one final landing. Each machine carries history, but the military still has to manage steel, fuel, electronics, classified equipment, and environmental risk. The ocean's SINKEX may look like the most dramatic ending, yet it is only one part of a larger cycle. Every ship, submarine, and aircraft eventually leaves frontline service, and its final job may be to train the next crew, supply the next mission, or disappear carefully into pieces. What once flew or sailed becomes evidence, training value, parts, scrap, or history preserved for another mission. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. Thank you.